Continuing our conversation with plate tectonics, we just want to remind ourselves, well, what is a plate and how do they move? So remember, our tectonic plates are these big pieces of the Earth's crust that are broken or cracked, and they consist of both continental crust and oceanic crust. So most of them have a combination of both types of crust. And they're just cracked pieces of the lithosphere, and they move in different ways. And they move relative to this plate boundary. So again, all these lines are the boundaries, the plates where the two plates interact together. And so we said at those boundaries, the plates can either move towards each other, which are the convergent boundaries. They can move away from each other. Those are the divergent boundaries. And the final one is transform, where they can slide past each other. So those are our three types of plate boundaries. Again, boundary, the spot where the two plates come together. So as we move forward in our tectonics discussions, that's what we're always going to be talking about, those boundaries, those spots where the two plates meet. And so what you did already was you looked at a given convergent boundary and you were checking out features, earthquakes, topography, remember, which is elevation, and volcanoes. And if you scroll down towards part 2 in your sheet, you should see this map, or not a map, excuse me, a table where we're comparing different types of convergent boundaries, or boundaries where the plates collide together. So you should have already looked into map A, B, or C, just a little bit to get some information. What we're going to be doing then is filling in what crust and features are found at each of those locations. So first of all, we're going to be looking at the crust. So remember, our two types of crust are ocean, which we'll start labeling as O, and continental, which we'll start labeling as C. That's, of course, our land crust. So this first one here, again, on either side of plate boundary, what type of crust do we have? So as we name crust at boundaries, it's going to be two parts. What do I see on one side? What do I see on the other side? So here in map A, we see ocean on one side, and of course, land or continent over here on the other side. So the first map is an ocean convergent, or excuse me, an ocean continent boundary. Second boundary here looks a little bit different. We see that the boundary is running in between two oceanic plates. So this one is known as ocean-ocean. And then finally, C spread out along here. This one is between continent and continent. So, you know, we do see parts of the ocean on this map. We do see some land on this map. But when we look at a majority of the boundary, it's sitting in between those two types of crust. So on your table, you should be filling in ocean-continent, ocean-ocean, continent-continent. Taking it to the next step here, we're looking at earthquakes. So we're going to fill in a short amount of information about earthquakes for each one of our maps. So I'm going to speed forward here to our earthquake diagrams. I'm going to fill in the information here, and you can go ahead and put it in your table. So for the convergent boundary earthquakes, we have kind of three things we're looking at. First, we want to know their location. Are they considered to be on or off the boundary? Are they symmetrical around the boundary, meaning same on both sides? And of course, with earthquakes, what is the depth of those? So here's convergent A. Looking carefully at the diagram, we see there are some earthquakes happening right at the boundary line, but a majority of them are happening off the line. So we want to record both of that data, on and off the boundary. Next thing we want to think about is, are they symmetrical? Do I see the same patterns on this side of the boundary as I do on the other? This side is, of course, very populated with earthquakes. Here, very little, if any. So it's mostly happening on one side of the boundary. And the tricky part is I can't accurately state, left side, right side, north, south, because I want to make sure I'm being specific to the features. So if I'm labeling a side, I would say land, or the continental side. And the last question here is depth. So looking carefully at our scale, we definitely have red, shallow earthquakes. We definitely have a plethora of orange and green, which is medium. We have very few blue. So I'm going to list out majority are shallow and medium. So that information should all be recorded in your table for Map A, earthquakes. Shifting gears here, keeping on the topic of earthquakes, but looking at Map B, same set of questions. Are they on or off the boundary? Again, we see several prominently on the boundary, while there are several off as well. So we're going to say on and off the boundary. Again, do they favor one side, or are they symmetrical on both? Hopefully you recognize this is just one side. And here, again, we don't want to say, oh, just the left side, right? We want to give it a feature. Here we said it's land. We can't say, oh, it's on the ocean, because this is the ocean side too. But we do have a few islands popping up, so we can make that our indicator. Island side. And finally, what is the depth of the earthquakes here? So we see a lot of orange and green. There are definitely red, and this time quite a bit of blue. So here we're seeing earthquakes at all depths. Final map for earthquakes, Map C. We see the boundary there. What are we noticing about location? There are a few on as well as a few off. And I'm going to use those words because compared to the other two pictures, it's a very low amount. What do we know about symmetry? If we look carefully, do we see the exact same earthquake on the other side of the boundary as we do on the right? No, it is not a perfect circle or perfect symmetry. So we're just going to say no symmetry. They're pretty scattered around. And finally, what is the depth of the earthquakes here? Clearly see they're mostly in red. That is going to be our shallow earthquake. So all this information should be filled in your volcanoes section of your chart. Take a quick pause and just think to yourself about something you see the same and something that's different. Okay, next thing we're looking at is topography. This one I felt like was the hardest one. This one we're looking at elevation. So with elevation, we're trying to recognize where we see high points and low points. So we're really focused on those same kind of terms. Are they happening on or off the boundary? Are they symmetrical? And what features might they turn out to be? It's really what we're thinking about. So here's our first one. I put the boundary line in there for you in red. We see we have two varying sides, right? Land versus ocean. The first one here I want you to recognize are these guys, right? Pretty big mountain ranges. So large mountains on the land. And when we think about their location, they're not touching the boundary. So I'm going to record off boundary. All right, and then again, looking at the ocean, it's pretty consistent, so not a lot of change in elevation or surface appearance here. But I was hoping people would recognize that this small pink area with the very deep is actually showing up right here on the boundary line. So I'm going to make another note for that, on boundary. I'm just going to say very deep. If you've got more information and time, you can go ahead and add that in, but hopefully deep reminds us that this is an ocean location. Okay, B, again, same questions. What do I notice on and off the boundary? Here we started with saying there's some high points near the boundary. We really see that same thing here. In this whole area, we're noticing that there's higher ocean crust material, and so less water needing to fill to the top. So it's kind of that light bluish color. So we do have higher elevations. Off the boundary. And then the other thing we're thinking about is symmetrical and any features. So not quite symmetrical, but we do have these features starting to pop up, right? We've got some islands forming in our diagram as well. All right, last one, convergent. This is, of course, continent, continent. So we're not looking at any oceans or really deep points. What we're really looking at is this guy right here. Huge mountain ranges. And those are happening off the boundary. They don't just cross over it, right in the middle. Okay, so now you have your topography section here. Again, thinking about your similarities and differences as we're moving forward. Last section here is volcanoes. And this one's pretty simple. We're just looking at their location. So again, we're focused on or off the boundary and if they are symmetrical or not. So here I have my boundary. These, of course, are off the boundary. And they are definitely not symmetrical. They're showing up just on the land side. Convergent, you can see the boundary. Definitely not as many earthquakes here, but they are still abundant off boundary. And again, not symmetrical. They're mostly on one side, and that side is, like we said before, the island side. Last but not least, our convergent C diagram. Here we have a few volcanoes, very few in fact, and really what we're seeing here is no correlation between this boundary and volcanoes. It's pretty rare to have one. So that's important to note, that there just isn't enough to make an accurate or full data set. So at this point you should have your entire map filled in. Feel free to go back if you need something else. Again, here's our boundaries. Just a little sneak peek. This is that stop A. This is our stop B. And finally our stop C. To finish this assignment and submit it, you have 2 questions here to think about. This one's asking, what did you observe or correlate? Thinking about similarities between the maps. So each statement here should have 2 maps being talked about. And what's the same or what's different? And then what could be causing all those differences? Because they're all convergent boundaries where the plates come together. So what could be causing that difference? Make sure you submit when you're done.